Okay, before break, I explained about the product rule, the rule of one of the rule for the differentiation. Okay, the next one is about the quotient rule. Please refer to page 7. The quotient rule of or kaidah nisbah. The let's say we have this function for quotient rule. Let's say okay, wait, the quotient rule. The quotient rule. Okay, let's say we have this equation y equal to fx divided by the gx. We have this ratio, this ratio equation fx and gx. The dy dx for this equation, the first order of derivative, the first order of the first differentiation, pembezaan pertama for this function or dy dx y prime or the dy dx or y prime equal to okay gx times the first f prime of x dy dx minus fx times the first derivative of gx. All of them are divided by gx squared, gx to the power of 2. That is the formula. You need to know this formula. You need to remember this formula. This is for the quotient rule for fx and gx. For example, let's say I have this question. Okay, given y equal to uh, 2x plus 4 divided by x plus 3. Y equal to 2x plus 4 divided by x plus 3. Okay, from this example, we can assume that fx divided by gx. Okay, the numerator is fx, the denominator is gx. We have fx and gx. So based on this question, the dy dx or y prime equal to, okay, we have this we need to do it step by step to identify gx and the and the f prime x. Okay, based on this example, we know that fx, the f prime x equal to 2x plus 4. Based on the rule of the differentiation, this is equal to the gx, the first derivative of gx is x plus 3. The first derivative is equal 1. So based on the question rule, this is equal to gx x plus 3 times f prime x2 minus fx. Fx is 2x plus 4 divided by gx equal to 1. And all of them are divided by gx squared, x plus 3 to the power of x plus 3 squared. So we just need to simplify the equation. This is equal to 6x, sorry, 2x 2x plus 6 minus 2x minus 4 divided by x plus 3 to the power of 2. So the answer is 2x. We can this one 2x minus 2x is 0. 6 minus 4 is okay, this is 6. So it's 6 minus 4. 6 minus 4 is 2. The answer is 2 divided by x plus 3 to the power of 2. Okay, that is how to find the derivative by using the quotient rule. Okay, the next one is about the inverse rule. the inverse rule of the derivative. For example, the dy dx is equal to 1 over dx dy. Okay, that is the inverse rule. For example, how to apply this concept? Let's say we have uh, this if you refer to the uh, uh, example on page 7, let's say I have this function x equal to 1 over 3y to the power of 3 minus y to the power of 2 plus 1. Okay, so we need to find dx dy. Sorry, find dy dx. dy dx. Find dy dx. So based on this equation, we can get dx dy. Okay, based on this question, we can get the dx dy. So this is equal to uh, based on this equation, we have a 3y to the power of 2, y to the power of 2 minus 2y. Please refer to the rule of the exponent. So dy dx, we have dx dy. Now we need to find the dy dx. This is equal to 1 over 2 dx dy. So this is equal to 1 over y squared minus 2y. Okay, that is how to apply the concept of dx dy, and also how to relate the dy dx and the dx dy. So based on the previous example, let's say, okay, this is dx dy, dx short, in general. Okay, based on previous example, this dy dx. So the inverse, the dx dy equal to we just inverse the process. This is equal to x plus 3 to the power of 2 divided by 2. That's the, for example, how to find the inverse. And then also, if you refer to this previous example, let's say this is a dy dx. The inverse dx dy equal to 1 over 3x squared minus 6x plus 2 and so on. That's the relationship between the dy dx and dx dy, the inverse function. 1 over 2 dx okay, that's correct. Okay, that's the inverse. Okay, the last one, the last rule of the differentiation, you need, they're quite more rule here. You need to know everything about this rule. Okay, the last one we call it as the chain rule, kaedah berantai. The chain rule. What is the chain rule? The dy dx, we can split. We can split this dy dx. We can divide this dy dx into the dy du divided by times du dx, where y is function of u and u is function of x. Please refer to page 7. In other words, we have two equations here. Y equal to f of u. U is equal to f of x. Y is function of u. U is function of x. So dy du is equal to the combination of the product of dy du and also du dx. For example, let's say I have this function given y equal to 2u squared and u equal to 3x squared minus 5. Let's say we have these two. Y equal to 2u squared. Y is function of u. The value of y is depend on u. And then at the same time, u is equal to 3x squared plus 5. U is a function of x. The value of u is depend on x. So the question is find dy dx. dy dx, the first derivative. Okay, we have dy and u and x. So dy du is equal to, first we need to find the dy dx is equal to, first we need to find the dy du, and then the second one is du dx. We can refer to the rule of the differentiation in order to find this the answer of dy dx. So what is dy du? dy du is based on the rule of the power of x. This equal to 4u divide times du dx. Du dx is equal to 6x plus 0 is equal to 6x. So we can just substitute u. What is u? This is u. So this 4 3x squared minus 5 times 6x. So this we can simplify this equation into the 24x times 3x squared plus 5. Okay, that's the answer. Out the du and dy du. So in general, when we want to find the dy dx, please remember we are talking about the y equal to fx. The equation, the y is a range, x is a domain. What x is input, y is output. From this equation, we can find dy dx. As comparison, let's say I have this function. Let's say z equal to f to the power of w. For this function, we can find dz dz dw. Okay, this equal to delta z divided by delta w. This also equal to delta y divided by delta x. Okay, that's about the derivative, the first part of this equation. Okay, for another example, I say if you refer to page 8, there are few exercise. I will choose a few example here. Let's say please refer to page 9, part A. Okay, given this equation, y equal to let's say y equal to 2x to the power of 3 minus 10x squared plus 4x plus 4x. Okay, the question is find the first one is f2. That's it. That is the question. The second one is the second question is find f prime 2. Okay, there are two questions. The first one is f2. The second one is f prime 2. What does it mean? What is the difference between these two questions? You need to know how to differentiate this question. The second one, we have prime here. Okay, the first one is f2 is ask you to find what is y. When x equal 2, y equal what? The value of y. We need to find the value of y. This question number 1. This question is based on topic 1. Berapakah nilai 2? Berapakah nilai y apabila x sama dengan 2? Okay, the second one is we have f prime x, f prime 2, f prime 2. This question is asking you about the question asks you about the dy dx. dy dx. The slope of the function. The slope of function at point x equal to. Okay, that I hope you can differentiate these two concepts. What is the difference between f2 and f prime 2? Okay. The first question, how to answer the first question? The first question, how to find the first question, f2? We just substitute x equal to x equal to into the question. This equal to 2 to the power of 3 plus, minus 10 times 2 to the power of 2 plus 4, 4, 2. Okay, this is equal to 2 times 8 minus 10 times 4, minus 10 plus 8. We just calculate this, the 16 minus 14, sorry, 440 minus 14 plus 8. We know that when x equal to the value of y is 16 minus 14 plus 8. The answer is negative 16. Now we have the coordinate point. The coordinate point is x equal to y equal negative 16. That's the question number 1. The question number 1 asks you about how, asks you to find what is y, the value of y when x equal to negative 2. Okay, that's the question number 1. When 16, 40, 24 plus 8, negative 24 plus 8. Okay, negative 16. Okay, the second question asks you to find f prime 2. Okay, this question at first, how to find the question? The question asks you to find the dy dx. First, we need to find the dy dx first. What is the dy dx? The dy dx, based on the rule of the differentiation, is a 6x minus 20. 6x minus 6x minus minus 20x plus 4. This the slope function. This also known as a slope function. Slope function. It's also known as the slope function. Fx 6x minus 20x plus 4. The slope function. So these are the slope function. F prime 2 means that we need to find what is the value of the slope when x equal to. So we just replace this function, x into 2, x, substitute x with 2, x 6 times 2 minus 20 times 2 plus 4. We know 6x to the power of 2, right? Sorry, to the power of 2 plus 20 times 2 plus 4, the answer is negative 2. Okay, this is not the value of y. This is the slope of y of fx at point x equal to. The difference between the f2 and f prime 2. So when we're talking about the dy dx, indirectly we find we are talking about the slope of the function at the given point of x. Okay, that the difference between x1 f2 and f prime 2. Okay, let's say we look for another question, another example. Okay, let's say for example, I will share you. Let's say, for example, we need to find the slope of a tangent line. The slope of the tangent line. The slope of the tangent line for y equal x squared at point 1 and 1. At point 1 and 1. Okay. We need we have a curve here, y equal to x squared, and then at point 1 and 1. Okay, how to draw this equation? This is the basic. We call it the basic quadratic function. We have this quadratic function. Let's say y equal to x squared at point 1. I will show you how to let's say, okay, wait a few minutes here. I will share with you uh, the graph. Okay, I will draw, for example, let's say, what we call it, online teaching, Desmos. Okay, I will draw the graph, and then I would like to share with you the curve of y equal to x squared. Y equal to x to the power of 2. Equal to 1. Let's see at this point. Okay, I have this curve. Okay, I have this. Wait a few minutes, yeah. Let's see. Okay, I will pass this. Okay, I hope you can see. Okay, this graph for. Okay, okay, this line. Okay, this graph is a y equal to x squared. Okay, this graph is y equal to x squared. Okay, let's say the question is as you find the slope of the tangent line at point. Okay, again, this graph y equal to x squared. Okay, we need to find the graph, the slope of the tangent line at point 1 and 1. Okay, this point 1 and 1. Okay, this point is one of the coordinate point. In other words, we need to know what is the slope of the graph at this point. Okay, the horizontal line is x, the vertical is y. So in order to find the slope of the tangent line or the slope of the graph at this point, the first slope of y or slope of tangent line at point 1, 1. What we need to do is we need to find the dy dx first. The dy dx for y prime, or this question, is equal to x. So when x equal 1, y prime, when x equal 1, the answer is positive 2. So in other words, when x at this point, the slope of y slope equal to positive. The slope is positive. This is also known as the slope of the tangent line. Slope of tangent line. What is a tangent line? Okay, tangent line is a straight line. Take your ruler, you just draw this line. One line that tangent to the curve at this point. Let's say I draw it in a what color we have here? Let's say a blue one, blue color. Okay, I draw this curve. I draw this line. I hope you can see here. Okay, I have this point here, this line, the blue one. this line is, we call it as a tangent line. What is a tangent line? Tangent line is a straight line. Tangent line is a straight line, is a linear line that they have one point. That line, the tangent line, has a one tangent point with the curve y equal to x squared. Okay, that, so we know that the tangent point occur at this point when x equal 1 and y equal 1. At that point, the slope of the curve and the slope of the tangent line are equal. What is the value of the slope? The slope is equal to. So for this tangent line is a straight line, linear in terms of y equal to mx plus y equal to mx plus c. So in other words, with m equal to, and then the next question is find the equation of the tangent line. What is the equation of the tangent line? With the value of m equal to, in other words, we need to know what is c. What is c? Let's say for the example, we know that the tangent line y equal to 2x plus c. 2x plus c. When x equals 0, y equal what? What is the value? What is the value of y? So based on topic 1, I hope you can you refer to topic 1. We can find the linear equation by using this equation: y equal to y1 equal y minus y1 equal to mx plus y equal to y1 y minus y1 equal to mx minus x1. So based on this equation, we need to know what is m. Now we know m is equal to, and one of the coordinate point. One of the coordinate point, we can apply this coordinate point with point 1 and 1. Okay, so the tangent line is equal to y equal 1, y minus 1 equal to 2 m x minus 1. So this y equal to 2x minus 2 plus 1. So the answer is y equal to 2x minus 1. So this tangent line, the equation for this tangent line is y equal to positive 2x minus 1. Positive 2x minus 1. That's how to find the tangent line based on the linear equation of that line, and also we can apply the dy dx, and that is the use of the dy dx for the tangent line. Okay, for your homework. In order to help you to improve your understanding. Okay, that is your homework. Okay, let's say I have this point. This point is x equal negative 2, y equal 4. Okay, the same question is find the equation of the tangent line. Find the equation of the tangent line. Equation of the tangent line. At this point. At point x equal negative 2, y equal 4. Okay, that is your homework. Okay, you will get the answer. The slope is negative. Make sure the slope is negative. Because at that area, as you can see here, the curve has the y is the slope the shape of the slope is negative, because when the value of x increase, the value of y will decrease. Okay, that is your homework. Okay, that's for the part A of about this topic. That's about the basic concept of the differentiation. Okay, any question so far? Any question?
No questions, doctor.
Okay, now I will move to part B. I hope I can finish the part B. Okay, the part B is about the application, the application of the application of differentiation. Okay, this part B, I start with the what does it mean, what means by the increasing function or decreasing function. Okay, I hope you have this lecture method, this note. Please refer to the UKM folio. This topic is quite difficult because there are so many rules you need to know and that you need to apply in economic and business. Okay, the increasing function refer to the situation when uh, the uh, the slope of the tangent line is positive. If you refer to the previous example, if you find the slope of the tangent line is positive, at that point or at the interval at all point of x where the slope is positive, uh, we can conclude that at that area the slope is increasing. That's one of the concept. But by contrast, if you as a comparison, if you find that the first derivative dy dx is negative at any point for the curve, we can conclude that at that point or at that area that near to the point the slope is the function is decreasing, or in other words the slope is as the function as the positive slope. For example, let's say I have this point, I have this okay, you can refer to a part B. Okay, for part B, uh part B of our lecture note. Okay, uh let's say I have this function y equal to 3x squared. Okay, let's say go back to the function. Now I have this function, this cubic function. Let's say y equal to the figure. Okay, let's say I have this y equal to x to the power of 3. There's a cubic function minus 6x squared plus 24x plus 2. We have this cubic function. Okay. Now I would like to determine where the function is increasing or decreasing. Or in other words, we need to determine where the function is the area where the function has a positive slope, or the area where the function has negative slope. We need to identify the slope of the function, the positive area of slope and negative area of slope. Okay, in order to find the function where the area of the function where the slope is positive or negative, we can apply the dy, we can apply the dy dx. For example, for this case, we just find the dy dx or y prime equal to please you need to know the rule of the exponent, the rule of the differentiation is 3x squared minus 18x plus 24. Okay, and then at the first step we need to equal all this function to 0. We need to identify the area where the function has a negative slope, zero slope. The slope of the function is 0. So for this case, you can apply the quadratic formula. You can use your calculator. Okay, I just skip the process. We know that the answer is when x equal 4 and when x equal 2. At this point, when x equal 4 and x equal 2, we can conclude here that the slope is 0. The slope of this function y4 is 0. Y the prime 2 is also equal. Is also equal. Is also equal 0. That is the based on this concept, we can conclude that when x equal 4 and x equal 2, the slope is 0. So uh, 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 based on this example, what we can do here is, let's say I draw this line when x equal 2 and x equal 4. At this point, we know the slope is 0. The slope is 0. Y is 0 and y prime 4 is 0. Now we need to identify what is the sign. I would like we need to confirm. We need to identify the slope of the function before and after this point. Before and after this. Before and after this point. They also known as the critical point. Titik genting. Critical point. It's also known as the critical point. So let's say I choose one value of x, but the value is less than 2. Let's say 0. I choose one value of x. The value of x, let's say, is 0. Okay, so y prime, we know that this equal to 3x squared minus 18x plus 4. If x equals 0, 3 divide times 0 minus 18 0 plus 4, the answer is 4. That is positive. So at that area, we know that at that area, when f equal 1, let's say when f equals 0, for example, the fx, y prime x is positive. So in other words, the slope is positive. When the slope is positive, we can conclude that at that area, before 2, the function is increasing because the slope is positive, increasing. Now I need to choose any value of x between 2 and 3. Between 2 and 3. Let's say I choose 3. Between 2 and 4. We need to find the value of x between 2 and 4. For example, let's say I choose 3. So now we can calculate the slope of the function, the value of the first derivative x when x equal 3. 3 times 3 to the power of 2 minus 18 times 3 plus 4. You can get the answer is negative 3. So the slope of the function is negative. So negative means the function is decreasing. The function is decreasing. Now, the same, based on this same concept, now I need to choose the value of x that greater than 4. At 4, the point is the slope is 0. Now I need to choose the value of x greater than 4. Let's say 7. I choose 7. And y prime 7. So the 3 times 7 to the power of 2 minus 18 times 7 plus 4. You can get the answer is, I think the answer is it's quite big here. 3 times 7 minus 18 times 7 plus 4. The answer is I think it's 25. Maybe I think the answer is 25. 3. Yes, the answer is sorry, it's 24. The last one is 24. Minus, sorry, the minus 24. This is not 4, 24. 24, 24, 24. This is 24. The answer is not 45. Is positive. So now we know that after 4, after x equals 4, the slope y7, the slope is again positive. So the function is increasing. The function is increasing. So based on this finding, we can conclude that before 2, before x equal 2, the function is increasing. What does it mean? The function is increasing like this. Between 2 and 4, the function is decreasing like this. The function is decreasing. After 4, after x equals 4, the function increasing again. So we can conclude here that when x less than 2, the function is decreasing because there's a positive slope, the positive value of first derivative. Between 2 and 4, the function is decreasing because the slope is negative of the value of the first derivative is negative. When x is greater than 4, the function is now again increasing since the slope of the function is positive or the value of the first derivative is positive after x equals 4. So in conclusion, we can conclude here that the function is increasing in interval. We can write here negative infinity and positive infinity. Negative infinity and positive infinity. And also when 4 and above, 4 and positive infinity. But the function is decreasing in interval. You can refer to page 2, part B, in interval 2 and 4, between 2 and 4. Okay, that's the value of the area of the this function, where based on this based on what dy dx, we can identify whether the function is decreasing or increasing. Okay. The next one is I think we are still in part B. The single lines don't give up. Okay, done. Okay, I will show you again later. Okay, based on this concept. Okay, the next one is about the application of weight of chains. Application of weight of chains. Please refer to page 2. Application of weight of chain. The first application is about the, let's say, we have a revenue function. Again, we have a revenue function. Revenue function. Let's say we have this revenue function. From this revenue function, we can find the marginal revenue. Marginal revenue, hasil sud in bahasa Melayu. The hasil sud there is a MR. MR and TR. Okay, how this is one of the concept, and then also before this we also have total cost. Total cost, there is a TC. From total cost, we can find the marginal cost. To refer to your economic cost, we have this concept, MC. Okay, from total revenue, TR, if you have a TR, the total revenue, the first derivative of TR, dTR dQ, we will get the MR, marginal revenue. And then from total cost, the first derivative of total cost, dTC dQ, we will get the MC. That is the first connection of marginal revenue and total revenue and marginal revenue, jumlah hasil dan hasil sud, and total cost and also the marginal cost, TC and MC. Okay, what is MR, marginal revenue? There is changes in TR divided by changes in Q, whereas MC is equal to changes in TC divided by changes in Q. So this is also equal to dTR, the first derivative of TR, dTR divided by dTQ. For MC, this is equal to dTC, the first derivative of TC is also equal to MC. For example, let's say I have a TR equal to 30 Q minus 0.3 Q squared. 30 Q minus 0.3 Q squared. First, we need to find MR at Q equal to. What is the value of MR at Q equal when Q equal to? So, first, in order to find MR, what is MR? MR equal to dTR divided by dQ. dTR divided by dTR divided by dQ. So this equal to 30 minus 0.6 Q. Okay, this is the equation of MR. So when Q equal to, what is MR? MR equal 30 minus 0.6 times 2. So the answer is 30. If you refer to the our 1.2, is this equal to 28 divided 0.810. This is the value of MR. Okay, the next one is about total cost. Given the total cost is equal to 0.1 Q squared plus 3. Let's say given this total cost function. Total cost function. Okay, let's say find MC. The question is, let's say find marginal cost at Q equal 4. The question is asked, find marginal cost at Q equal 4. When Q equal 4, what is MC? That's about the question. So we need to find MC. What is MC? How to find MC? MC is the first derivative of total cost, dTQ dC. This is equal to 0.2Q plus 0. Because there is a constant. Okay, dTC MC equal to 0.2Q. So when Q equal 4, MC equal to 0.2 times 4, the answer is 0.8. That's about the DT of MR, MC, TR, MR, TC, and MC. Okay, the last one for today. If you refer to page, 3, okay, for page 3, okay, we have one concept here, the elasticity. We call it as the elasticity. Okay, elasticity measure how change how change in one variable will affect another variable. Okay, that is one important concept, one of the important concept in economics. Uh, the elasticity or keanjalan. Okay, keanjalan. We'll measure how change in one variable will affect another variable. In this case, there are many type of elasticity. For this class, we will apply the demand elasticity. Uh, Based on the concept, we will measure the percentage change in quantity demanded given the percentage change in price. If price change by 1 unit, what happened to the quantity? Okay, there is a we will apply this concept dy dx by using this formula. E, the elasticity, the demand elasticity equal to dq divided by dp times p over over q. Okay, based on this example, okay, I hope you can read by yourself the concept of demand elasticity. I will show you the example here. Okay, please refer to page 3, 4, and 5 for this part. I will show you. I will explain this example. Let's say given we have demand equation. In topic 1, I explain about the more detail about the demand. Again, let's say we have P equal to 20 minus 0.2 P 2Q. Sorry, P is price, Q in quantity. The question is, let's say we need to find the demand elasticity. Calculate the demand keanjalan permintaan demand elasticity at Q equal 10 and interpret. What is demand elasticity? Demand elasticity is E. This is dQ dP times P over Q. That is the demand for elasticity. So we need to find the dQ dP. Okay, from this equation, okay, at point Q equals 0. Okay, first we need to find the dQ dP. From this equation, we can find dP dQ. So this equal to negative 0.2, negative 0.2, because P equal to 20 minus 0.2 Q, the dP dQ negative 0.2. So based on this, dQ dP, the inverse, the rule of inverse equal to 1 negative 1 over 0.2. Okay, now we know what is dQ dP. So we know Q equal 10. Okay, in this case, Q equal 10. And P equal 20 minus 0.2. We just substitute Q equal 10 in the question. Okay, the answer is when Q equal 10, P equal to 18. So therefore, dQ dP is 1, negative 1 divided by 0.2 times P over Q. P is 18, Q equal to 10. So the answer is negative. The answer is negative 9. I just calculate. So the answer is negative 9. Okay, that's how to find the demand elasticity. If you refer to this page again, okay, the answer is negative 9. Okay, for elasticity, okay, the correct answer is negative 9. The correct answer is negative 9 because there is the negative relationship between demand, quantity or demanded, and price of that and the price. The negative relationship between P and Q for demand equation. So but in order to interpret, we take the absolute value of the absolute value of the E. That is, if E is negative, the absolute value we just take the positive value. The positive value is positive. So since the E is less than 1, we conclude that the demand is elastic. Permintaan adalah anjal because the value of E, the absolute value of E is greater than 1. We just take the absolute value, ignore the negative. The real value is negative, but when we want to interpret, we just take the absolute value. So how to interpret? This value is referred to the percentage value of changes in quantity when price changes by 1 unit. So in order to interpret, you must write like this. At quantity equal 10, because we determine this at when Q equal 10. At Q equal 10, 1% increase in price will lead to 9% decrease. This 9 is also known as a 9%. No need to times 100. We just take this as a 9%. Since the value of the elasticity is 9, we assume that there is a 9%. We can consider it as a 9%. If price change by 9%, what happened to the price? If price increase by 1%, what happened to the demand? Demand will decrease because the real value is negative. This negative show that the negative relationship. When we're talking about price increase, the quantity demand will decrease. If we assume price increase by 1 unit, the demand will decrease. This word decrease, jatuh, berkurangan by 9%, sebanyak 9%. Jika harga meningkat sebanyak 1%, permintaan akan menurun sebanyak 9%. That's how to interpret the elasticity, to change the change in price subject to the change in the change in quantity subject to the change in demand. So in terms of the value of the elasticity, please remember the negative value, the negative sign show the contra relationship, the inverse relationship between P and Q. If price increase, demand will decrease, and so on. And the absolute value of E show the percentage changes in quantity subject to the 1% changes in price of good. Okay, that's how to interpret the demand. Okay, the high order of the okay, I think okay, that's all for today. I think for the next class, I will continue on this high order of derivative, and then I will continue to the part C. Okay, there's a next week class on 70. Okay, 70 is public holiday, I think, but I will let you know later whether we need to replace this class. Okay, this for next one, for next lecture. And then I think I will stop here. That's all for today. For the next lecture, I will continue on this section, page 6, part B, high order derivative. Okay, any questions so far before I end this meeting?
Sorry, doctor.
Okay, if you have you have a question, please you can ask now. Again, any question?
My friend, she don't know why she be quick to the meeting, and she want to join the meeting again, but no one allow her to
okay,
join the meeting.
Maybe now we are now we are at the end of the meeting. Maybe I have not received any notification because maybe we only have more than it's about just just 1 or 2 minutes left. Okay, it's okay. It doesn't matter if your friend have not managed to enter to my class, because I will check your attendance based on the because your attendance is automatically recorded by Teams. Okay.
Okay. Thank you.
Okay. I think that's all for today. Any question? Because we're now almost 2 p.m. now. I need to end our meeting. Okay, if there is no question, okay, I will stop now. Thank you for your attention. Okay, see you next week. We will continue on the next section, high order derivative, and I hope we can finish topic 6 next week. Okay, see you next week. Thank you.
See you. Thank you, Doctor.
Oke, sama-sama.